Question 4 of this exercise says ABC is an isosceles triangle right angled at C. So let's draw a figure for such a triangle. So here's a figure that I've drawn for triangle ABC. We want the triangle to be isosceles and right angled at the vertex C. Okay, so this angle here is 90 degrees, the angle at the vertex C, and also the triangle is isosceles, which means that the two sides which are not the hypotenuse will be equal. So AC and BC will be equal. This is the only possibility because the hypotenuse can't be equal to any of the other two sides. So AC and BC must be equal. Okay, let's write this fact. AC is equal to BC. Now we have to show that AB square is twice of AC square. So AB square, the square of the hypotenuse, is twice the square of AC. And this is actually really easy to show. We simply use the Pythagoras theorem and write an expression for AB square. So using the Pythagoras theorem, I'm going to write this in short. We must have the square of the hypotenuse. So AB square must be equal to the sum of the squares of the other two sides. So we must have AB square equal to AC square plus BC square. And this sum we can write as AC square plus AC square itself. Why? Simply because BC is equal to AC. So BC square will be equal to AC square. Okay, so if you want, we can write the reason also for this. BC is equal to AC. This is the reason. So we get AC square plus AC square or 2AC square. And that's it. This is what we had to prove, that AB square is equal to 2AC square. Okay, so this completes our proof for question number 4. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.